We are Team 9 of the Computer Science module Systems Engineering at UCL. This is the automatic system for gathering and visualizing patient well-being. In the past, there has been no cost-effective and non-invasive method of tracking an individual's well-being. GPs relied on their patients' honesty and their own inference to determine this. Additionally, it was difficult for the NHS to decide where to allocate resources to improve mental well-being within the area. As a result, the WellWellWell app was developed. It is designed to passively track a user's phone usage to predict a well-being score based on the NHS framework, the 5 Ways to Well-being. The app tracks phone usage to generate a predicted well-being score using machine learning, which the user can share with their GP or anonymously add it to a nationwide database for analysis and research by the NHS. These are the key requirements we identified during requirement gathering. The first refers to the application's core process that collects phone usage and pedometer data to generate a well-being score locally using machine learning. A local data management system is needed to allow users to view and control the permissions they give the application and to change any personal information as needed. The patient's reference numbers, such as their NHS number, needs to be recorded and used to share data with their respective GP. The data also needs to be visualized and shared as a PDF or text file. Collected data should also be stored and displayed in a simple and clear manner. To preserve anonymity, we needed to create an algorithm that randomized up to 30% of the data to ensure no individual is uniquely identifiable based on their postcode area. A data management system is required to organize the anonymously pushed data according to the postcode areas and time, and a framework was needed to be developed to visualize this data on the UK map by postcode areas. This is the system diagram of our app. The app can generate either a PDF or text file with the predicted scores and allows the user to anonymously push data to the nationwide database. To visualize the data, we made use of the Google Maps API with the data from the database and mapped GeoJSON files onto it, which describes the polygons to be highlighted on the maps corresponding to each postcode area. These were the technologies used in this project. The application itself is an Android app that primarily uses Java and inbuilt Android classes. We use JUnit and RoboElectric for testing the app. We used an Azure MySQL server to host the database and establish communication between the Android application and the database, as well as the visualizer application and the database. The web database visualizer application's backend was implemented using Node.js and embedded JavaScript template, EJS, for the front end. For visualization itself, as mentioned before, the Google Maps API and GeoJSON files were used to highlight specific polygons on the map corresponding to each postcode area. The app's homepage shows the predictions made in-app. Every week, the score updates and the user is given the opportunity to provide feedback on the prediction. The user is also given the option to share their data anonymously to a nationwide database for research by the NHS. The app works by tracking the user's phone usage and pedometer data. This corresponds to 4 of the 5 ways to well-being: connect, be active, take notice, and keep learning. The data collected is stored in-app for the user to access at any time. The user can then choose to share or save their data as a PDF or as a text file. The data is visualized in a simple, clean manner. We also designed a method of visualizing the data collected. It stores well-being information by postcode area. You can also see data for specific weeks. By highlighting over an area, you get to see its average score and the number of records there. The data is visualized in a clear and intuitive manner. As for our achievements, we managed to complete all but one of our requirements, achieving 100% completion of all our key functionalities and 95% completion of all optional ones. The unachieved requirement of developing a similar application for iOS was solely due to the limitations iOS had on their apps gaining access to phone data usage, which is key to the core process of this application. In addition to the Android application, we also created an open source API for data visualization on the UK map by postcode areas that can be used for visualizing any geographical data, such as crime rates, unemployment rates, car accident rates, and many more. Finally, the WellWellWell app is intended to be handed to 25 GP practices to test on 5,000 users upon completion.